Pokoknya korang kalau nak download video tu jangan download terlalu tinggi lah. Takut nampak habis kan. Okay, enough that. Alright. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon to everyone. I start again. Again, I already said in my prep topic previously is that we focus on the questions that is worth to be discussed. Soalan yang saya assume ramai tak boleh nak jawab. Soalan yang mudah tu kalau boleh cuba kurangkan sebab masa kita kurang. Nak fokus pun better kita fokus kepada ni. Alright, I will start with your handwritten assignment first. That's the reason why. Your handwritten assignment is that part A video tu saya lebih kurang sama je semua video kan. Alright, for the logic chapter hampir semua boleh jawab. Hampir semua boleh jawab dengan markah 18/20 ke atas. Markah assignment yang tersilap tu saya akan baiki, jangan risau. Saya tak boleh nak masuk balik lepas you all complain tu, saya tak boleh masuk balik. So saya akan baiki lagi, don't worry. Focus on your final exam first. Your logic, most of you guys dapat 18/20. Ada 20/20 punya ramai. So saya tak risau yang tu. Okay, proof techniques Proof techniques. For the first question, refer to my assignment part A handwritten. Okay. Nanti saya buka saya punya screen. Tapi sekarang ni korang buka dulu okay. Okay, saya harap tak ada student masuk sangat lah lepas ni sebab saya nak fokus. Kalau saya tak nak tekan admit. Adalah nanti tapi kurangkan lah. My entire screen. Okay, I suppose you guys can see my sekejap belum. Okay, you guys can see my screen right now. Okay, we start by discussing the assignment first. Ada lagi nak masuk? Hai, baru cakap. Oh, yes sir. Oh, Devendran. Sorry. Okay. Part A mana? Okay. By using direct method, prove that the sum of two even integers is a multiple of 2. Okay. Most of you guys get the first step right. The proof 2A. You start with a definition first. You assume that there is an even integer, katakan 2k1, and another integer b, 2k2. You all betul kat sini, most of you. If possible, do not let as 2k only. Contoh kesalahan student ialah dia letak satu variable saja, macam ni. A equals to 2k, B equals to 2k. Sama k dengan k ni. Kalau boleh elakkan, guna alfabet yang berbeza. Menunjukkan dua integer ni mungkin even integer yang berbeza. Okay? So don't do on the right one. Okay. Sum of two integers. So you let A plus B equals to 2, k1 plus 2, k2. And then you put factorize k1 plus k2. And apparently you jawab 2 becomes k3, and this k3 is defined as k1 plus k2, and this k3 is an integer as well. Alright, tak ada masalah kat sini. The problem is at your last line, most of you guys, you don't answer back the conclusion. You say like this, conclusion, suddenly you letak, okay, salah you letak jalan kerja dah sama. Conclusion you, sum is a multiple of 2. Ada lagi nak masuk, saya nak habiskan dulu. Okay, from here to here, is it suddenly you can really say that this is a multiple of 2? Kalau jawapan yang paling cantik, obviously you know about the multiple. From the student's answer, I bukan kata you tak tahu. I don't have the proof, that you know that this is a multiple of 2. So, there is some marks, ni yang lama punya, tak apa abaikan. There is some marks allocated to this statement. 2, ni adalah 2, multiple mana? Multiple yang kanan. Student yang jawab macam ni dapat markah penuh. 2K3 is a multiple of 2. Daripada definisi, if A divides B, then A is a factor or divisor, B is multiple. So the students who show this statement last like this, you tak tulis ayat pun you dah betul. Ini markah yang kehilangan sedikit. Saya tolak 1 ke 2 saya tak ingat. It does not say that you don't know this. Some of the students dia dah tahu dah. Oh, 2K3 multiple of 2 lah. Tetapi I want a statement that you know, a complete one that shows that you know the definition of multiple. Bukan kata you tak tahu, you kena proof yang you tahu. So ini yang kekurangan markah kat situ. My point is right now, the conclusion, this symbol must be reflected with this one. Saya tanda ya, ini. Reflect yang kanan ni. Kalau you tunjuk ni, dia macam hilang certain information there. You don't show that 2K3 is actually a multiple of 2. Ada soalan? Admit je. Badri Hilmi. Okay. Hai, ramai ya. Okay, ada soalan setakat ni berkenaan tu? Ada soalan, chat. Lepas ni kalau, okay, tanya-tanya. Silakan. Cakap, siapa nak tanya ni? Weh, off mic yo. Kalau tak ada soalan, off mic. Oh, saya tahu. Student tu dia tak nak join. Dia cakap record. Saya dengar dia cakap, weh dia record tu. Maksudnya dia tak nak join yang ni, dia nak dengar yang record saja. Pandai korang. I tak kisah, I tak peduli. Okay, do you have a question for the first one? You guys. No, okay. If you silent, it's okay, Devendra. If you don't have, you just silent, that's okay. Because I will try to read the chat, because when I open my screen, I don't look at the chat anymore, all right? But thank you for the feedback, by the way. We concentrate on the next question. All right. This question, if you look at my bonus video, the proof of divisibility one-to-one function, you boleh jawab actually. Kecuali yang last ni, saya tak ingat. Saya ajar tak dalam video tu. That's okay. Let me teach you. Every proof does not necessarily about the even and odd question. You already know that by this time being. It can also be a proof of divisibility, a proof of one-to-one and on-to function. It can be a proof of relation, reflexive, symmetric, antisymmetric, transitive. Itu pun proving tau. Proving a logical equivalence, also a proving, right? Semua chapter kamu sebenarnya ada proof. Saya pernah cakap dalam kelas face to face dengan online. So, alah, dah nak masuk lagi. Okay. For the second question, 2B, Okay, for 2B, let A, B, C be integers by using direct method proof. Okay, we start with the first establishment first. If A factor of B and B is a factor of C, then A is a factor of C. The Consequent, the conclusion, the antecedent, the ni conclusion dia. Ini dia punya condition, implication dia, conclusion dia. So we start with establishing this. Let A is a factor of B, then B equals to A K1. Where I get this is from the definition of divisibility. And also I let B is a factor of C, then it means that C equals to B K2. This K1 is an integer. This K2 is also an integer. Okay. Next comes your idea to show as C equals to B K2, C becomes A K1 times K2. Dapat daripada line yang pertama ini. K1 is an integer, K2 is an integer. K1 times K2 becomes another integer, K3. Alright. We don't finish yet. Kalau you kat sini kalau you guys dah jawab, oh, then A is a factor of C. Kan? Let's say ada student tiba-tiba dia letak conclusion. Dia tak relate ni. Macam ada benda yang ayat tak habis. There is some missing statement that connects A K3 suddenly, oh A is a factor of C. Pelik lah kan. So inilah point yang sama yang saya cakap untuk soalan sebelum ni. Dia tak habis. Dia tak jelas. Apa yang jelas kat sini is that A is definitely a factor of multiple of A. Betul? A adalah faktor kepada multiple of A. Memang betul lah. So, apakah A K3? Maka A divide C because A K3 is equivalent to C. This whole idea, every line is important. Nak lagi cantik, boleh saya letak K3 is a integer as well. Tapi itu kalau student tak tulis, saya bagi markah juga. Okay, any question regarding divisibility kind of proving? Saya tengok sekejap. Okay. Semua clear? I hope you should be clear. We go to induction question. Okay. Okay, untuk induction, saya tak akan jawab C1 apa tu by using mathematics. Not surprising lah, because you memorize you memorize the step, you know how to apply the summation of the left hand side to be equal to right hand side. Memang ramai student boleh jawab. Saya assume dalam 80% boleh jawab dengan betul. Tetapi yang last tu ada yang perasan, okay, ada yang saya tersilap sikit dekat soalan tu, saya perbetulkan balik, tapi still saya bagi markah. Yang saya tak bagi markah yang orang yang silap yang ini. Okay. By using this formula, see it is established that 1 plus 3 plus 5 plus until n minus 1 sepatutnya. Tapi saya bagi sebab you all ada yang betul lah kat sini. Okay. When we already prove this one to be correct, yang you salah tu dekat sini. 117 tambah 119 tambah 221 tambah bla 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 tambah 2017 tambah 2019 tambah 2021 equals to what? Okay. Yang salah tu dia guna direct formula macam ni. Okay, we start with the question first. How to use the formula? Huh? The formula, sekejap. Okay. Let's try to check 1 plus 3 plus 5. This is a very small series sequence that you know already the answer will be 9. You let n equals to 2n minus 1. Silap. You let 2n minus soalan ni saya silap tulis tu. Sekejap. Pemadam. Sekejap saya tengok nota sekejap. Saya silap tulis tu. Ini dia. Saya silap kurungan tu kan? Bukan. Ni soalan ni saya silap. Ini. Jadi n squared kan? Ni saya soalan lama ni. Kesilapan saya tu saya bagi kat, maka kalau budak buat silap, saya bukan kata saya tak bagi. Yang saya tak bagi kalau kamu apply tu silap. Okay, so dia soalan dia ialah 2n minus 1 equals to n squared. Okay. Alright. Therefore, okay, I continue. You let 2n minus 1 equals to 5. Therefore, this n is become 3. When you apply in the formula in the blue line here, the summation from 1 plus 3 plus 5 equals to n squared or 3 squared equals to 9. Okay. The common mistake that my student do is that they use this n instead of 3, dia ambil n equals to 5. Dia ambil nombor belakang ni. If you take the last digit and you assume that to be the value of n, then you will be wrong. Because the n here represents the order of the element. Element yang ketiga, the third element, not the value itself. Maka bila kalau student jawab macam ni, dia jawab 1 tambah 3 tambah 5 sama dengan 5 kuasa 2 sama dengan 25. Sudah? Tidak betul. It's incorrect. You take the last element here, you let it to be the last element here. Right. Now, there is the first mistake that my students did, and I go to the next mistake. So the students who get this point correct, they do the second one. The second mistake is that they do this. Let 2n minus 1 equals to 2021. Then n will be 2022 divided by 2 becomes 1011. Lepas tu jawapan dia cakap 117 plus 119 plus until 19 plus 2021 equals to 1011 squared. Dia jawab macam tu. Okay, this is the second mistake. This summation is not equal to 1011 squared because this formula applicable when you start from 1. If it is from 1, kalau soalan dia 1 tambah 3 tambah 5 bla 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 sampai 2021, yes you can use. But this question has a little bit of bukan spin lah kan. Dia kata tambah daripada 117. Alright? So actually you need to minus something here. Something needs to be done here. You can leave 1011 here. Boleh, tetapi you kena tolak something. You must minus something. you must minus the summation from 1 plus 3 plus 5 until berapa? Until 115. You must minus this part. So this value, I already teach you how. You should already know what is the summation from 1 until 115. Then the answer will be that thing. Saya dah ajar you cara. Student tak buat, some of the student dia tak tolak. Dia terus dapat 1011. Ini kesalahan kedua. Ada soalan setakat ini? Are you still with me? Ada yang baru nak masuk lagi? Ada. Oh. Yalah, saya dapat mesej semalam. Ada student kata, there's some students said that they are arranging their new hostel for today. Like I said, I already answered them. That's fine, I record this video. And if we have more time, kalau tak mengganggu, sebab kalau saya buat, the best that I can do is tomorrow, right? Because you already start your exam and I don't know what is your schedule. Kita cuba yang terbaik je lah. Tapi lepas ni, I really prefer wise question that you cannot answer. Again, yang hari ni saya mention dulu sekarang ni, right now I mention the common mistake first. And I already only focus on the common mistake that many students did. For the time being, we already discussed the proving techniques. And do you have any question for the time being? Kalau ada boleh tanya. Jemput minum. Tak cukup besar. Okay. Give me a chance to take a break for a while I try to communicate with you. Kita dah bincang dua soalan. Is there anyone here from the red zone? Ada tak? Left the meeting. Ada tak daripada red zone? Ada semua daripada green zone That's good. That's good. When you enter here, please. Oh, Atika baru masuk. Kita dah bincang dua soalan tadi, jangan risau, saya dah record. After this you can take a look. Kita dah discuss dua soalan tadi. Ada tak daripada red zone kecuali Atika lah. Atika kata dia tak boleh datang kot. Semua dah balik hostel ke? Siapa yang tak balik hostel lagi? Tolong kita bersembang sekejap. Try to communicate with me please. Kalau tak saya rasa macam
saya tak balik hostel lagi.
Oh, you tak balik lagi. Kenapa? Malam ni balik. Oh, you guys on the way balik lah. Okay, may I know where is your hostel? You are the FCOM students, right? Hostel semua kat DRB Highcom. Memanglah, boring ni, I sorang-sorang ni. Semua kat DRB Highcom, bukannya kat Pekan. Bukan UMP Pekan Okay. So may I know, how will you travel there? What is the method for you to travel from DRB Highcom to UMP Pekan? Is there a bus? Public transport ada? Saya pernah pergi DRB tu. Even my students also there. They say got bus. They say tak ada ikutkan, tapi ni bus UMP sediakan. Our management is a haywire right now. Tumpah member. Janji sampai Yelah, memanglah. Bas takkanlah disedia banyak. Macam mana kalau student tertinggal bas? Macam mana kalau student terlewat bangun? Samu tidur banyaklah kau. Jalanlah. Larilah pergi. Apa ni? Samu tidur. Grab. Okay. Okay. Janganlah macam tu Cikintan, UMP 5 star. Tahu itu peli tu. Pun tak mau cakap macam tu. Because as much as I have many things to say to our management, but I try to keep it discreet. Not that discreet, man. Discreet, DISCREET. Because I'm trying to think more on the solutions. UMP tak cukup hostel. Tak sangka dia bila dia ada di, wah banyak duit. Oh sebab tu dia tak pernah duit hostel kot. Dia guna sikit untuk beli. Saya jakung masuk UMP bukan selawa sangat. Kau ni peli ke apa? I tak faham lah. Korang. Tapi memang lawa. Okay, we will start in 2 minutes more. Memang lawa. I try to waktu malam. Weh korang, UMP Pekan tu jangan jalan malam-malam. Setengah tempat tu keras. Especially dekat JPPH. Waktu malam, please don't go there. JPPH Pekan. Oh, noted oh. Kau nak pergi apa JPPH Pekan waktu malam? Kau nak buat apa, Robin? Sana banyak benda berlaku lah. Yang melibatkan mistik, cuba kurangkan. I tahu blok lama I pun ada hantu di Gambang ni. Blok A1 ada hantu. Dia orang cakap. Sekarang ni, okay, right now this is my new office. Last week also we are busy to transfer. FCOM go there, right? So the lecturers from FCOM go there. This is the room of your dean FCOM. Your dean dah pergi ke Pekan. Seronok dia bilik baru, bilik besar. Aku dapat bilik lama dia. Nasib baik bersih sikit. Naik taraf, saya naik bangunan 3 tingkat setiap hari. Tinggi, sangat tinggi. Yeah, this is a good office as well. Alright. Ada lagi nak masuk tak ada? Sebab tadi bila saya mula bersembang ni ada lagi nak masuk. Alright, we start back on chapter 5, abstract algebra. Okay, let's do this guys. Ada lagi nak masuk. Stress. Sekejap, apa ni? Saya nak tanya, what if kita fokus on chapter 1 to 3 untuk final ni? Berapakah markah maksimum kita boleh dapat? By the way, Robin, you section I ke? Ke section 1? You section 1? Oh, patutlah. Saya tak pernah nampak nama Robin ni. Okay. I really advise you not to do that. Of course. Okay. If you focus on chapter 1 until 3, kejap saya nak kira kejap Saya boleh beritahu berapa portion markah, bukannya soalan yang keluar kan. Okay, if you focus on chapter 1 until chapter 3, the most you can get if you master everything from chapter 1 from chapter 3 is, I estimate 55. 55 only per 100. Yeah, I already answered it. It's around 55 per 100. There's quite a huge chunk of chapter 4 and chapter 5. The reason is because chapter 4 and 5 is not being asked during the test. Waktu test, kami hanya tanya chapter 1 until chapter 2. Chapter 3 tak tanya, tapi chapter 3 akan ada, tapi chapter 3 final ada. Chapter 4 pun ada, chapter 5 pun ada. So, what if we focus on chapter 1, 4, 5? Asal korang ni? Di pelik. Ong, chapter 3 paling senang. Kenapa tak mau Oh, maksud you dah master chapter 3, you tak nak study Ikut you lah. As a lecturer, please study all, but please prioritize the one you master. Ada dua cara belajar. The first one, you master what you already can. Okay, Ong, I really want to tell you this. Although chapter 3 senang score, yes, correct. Tetapi kalau you silap truth table tu, kan, truth table tu, you silap dekat some of the column, dia akan affect column at the right. Maksudnya walaupun you tahu jawab, make sure please all you guys, jangan careless mistake. Chapter 3 paling senang orang careless mistake. Saya dah jumpa. Kesian. Soalan 10 markah, dia silap sikit je dekat kolom ketiga, dia kacau sampai kolom ke kanan, dia hanya dapat 3 markah per 10. Okay? I advise you. Chapter 4 and 5 weak. Okay. So try to master the basics first. Chapter 3 tu jangan buat silap, jangan too overconfident. Please give a sufficient time as well. Ada yang fokus kepada chapter 4 dengan chapter 5 pasal dia lemah. Bagi saya, cover semua, prioritize chapter 1, 2, 3 dulu. 4 and 5, lepas tu. That is my way, ya. Okay, that is my way. Okay, now I will go back. Okay, chapter 4 actually tak susah, guys. Chapter 4 tak susah. I dah bagi tahu you must start line tu tally dengan conclusion. Tally dengan conclusion. Bagi saya, honestly, chapter 5 sahaja yang betul-betul susah. Chapter 4 actually senang. Kalau you tahu cara dia, kalau you faham soalan dia. You tengok bonus video lecture I. Bonus video lecture I tu bagi I paling mahal sebab dari segi, okay, because it is really good, not really good. I think it comes from my experience. I don't saying that from the slide, kalau korang perasan. Saya ajar bonus video lecture tu macam yang sekarang ni. I really don't look at the slide. I only focus what is the student cannot relate to. Apa kau dia selalu tak dapat tangkap. Okay, chapter 4 senang. Ubah mindset. Abstrak algebra yang susah. Even abstrak algebra tu lecturer math tak mau ajar. Kecuali saya dengan Dr. Syam. Yang lain tak mau ajar. Okay, now we go back to chapter 5. Get ready, guys. Okay, chapter 5. Determine whether, okay, Z11 star. In one of my videos of abstract algebra chapter, I already say there are some groups of Z. Ada yang integer saja. This is set of integer. Zn is still a set of integer less than n modulo n. Set of positive integer. Okay, before I proceed, apakah beza? Okay, what is the difference between the A and B? The first one is inclusive from the first one, A. The first one, it includes every integer out there, including a negative 1. Negative 1,000, negative 10, 0, 1, 2, 3, 4, until every integer. It's not limited to. It's an infinite set. That is an integer. B, okay, Z. I must define my n first lah, better. For example, a Z5. Z5, it means the set of not positive, non-negative. Dia termasuk kosong. It includes 0, 0, 1, 2, 3, up until 4. And then when you do the Cayley table, you will try to modulo n. Ini ada dalam video tapi saya nak clarify. Zn star is a set of positive. Yang ni positive. Less than n, then you modulo n. So the difference between B and C is that you just not include 0. the difference between the first one and the second one. You just don't have 0. So that is the difference between Z5 and Z5 star. And then you have one more that I suppose, nanti I beritahu pasal matrix, don't worry. Matrix pun saya ada ajar. UN. UN is a set of positive integer less than n relatively prime with n. Sorry buruk. N. Okay. Therefore for D, let's say I take Z4. U4. In my mind, it must be positive and it must be less than 4. The problem is relatively prime. Relatively prime kacau. So instead of you list down 1, 2, 3, actually it's not 1, 2, 3. You must try to find GCD between 4 and 1. It must be 1. Then it is relatively prime. However, GCD, greatest common divisor between 4 and 2, is not 1, it's 2. Therefore, 4 and 2 is not relatively prime. So the element inside U4 is 1, 3 only. So there are various kind of representation of G here, group. Z, Zn, Zn star, Un. Please master every kind of this. If you don't know, the starting point here, kalau you silap, if you do, saya takut ada orang Arab kat sini. If you mistakenly identify the elements inside the G, then everything you done at the below will be wrong. This is the fundamental part. Do not do the mistake at the definition of every sets. Okay. Now Z11 besar, saya tak akan buat balik. Saya buat yang kecil je tak ada masa. Z5 star is an abelian group by checking all the properties of the abelian group. Every one of you guys during assignment, all of you know the characteristic of the abelian group. However, you do it, some of you do some mistakes. Okay, for Z5, you kena tahu dulu what is the element inside Z5. Star. Star ni maksud tak ada 0. So tak payah letak 0. It's 1, 2, 3, 4. Okay. Then you do the Cayley table. Cayley table pun ada yang silap, sayang. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay. In the question it say under multiplication. So sini multiply. In your mind right now, it must be multiply, then you mod 5. 1 times 1, 1. 1 mod 5, 1. 2. 1 times 3, 3. 3 mod 5, 3. 4. 2, 4. When you arrive at this point, 2 times 3, 6. 6 mod 5 is modulo from chapter 1. If you fail to master the concept of modulo, tak boleh lah. 2 times 3, 6. 6 mod 5. What is the remainder when 6 divided by 5 is 1. 1. 3. 3. 1. 9. 9 mod 5. 4. Narut. 4 lah. Sorry. 12. 2. 4, 3, 2, 1. Cayley table, always around 2 to 3 marks at most. Please do this correctly.
Sir nak tanya.
Boleh?
Z5 elemen dia bukan 1, 2, 3, 4, 5
5 tidak termasuk 5. Tidak termasuk. It must be less than n. Tak boleh masukkan n.
Okay, sir.
Alright. Jangan masuk 5. Kalau you masuk 5, sudah salah. Okay. Set must be correct. The Cayley table must be correct. Baru yang bawah tu betul. Kalau atas dah salah, if you the top one is already wrong, for example your friend, if you put 5 here, bawah salah lah. Bawah kena kolak markah lah. Banyak. And don't be surprised, abstract algebra 12 markah kat sini for this assignment. Kalau budak boleh jawab, dia betul banyak markah. However, dia salah sikit kat atas tu, dia effect sampai bawah, saya tak boleh nak bagi markah. That's why yang gagal kat situ sebab dia contoh termasuk 5. Kalau termasuk 5, 1 times 5, 5. 5 mod 5, kosong. Salah lah. Dia jawapan dia akan reflect bawah ni jadi salah. Okay. Delete. Alright, we start with the actual answer. Closure. Again, saya cuba tak lama sangat. Close. Kita ada 5 property. We have 5 properties, the closure. To master abstract algebra, you must master the definition. I said multiple times already. The basic definition of close is that A binary operation with B will produce some new element. Let's say C. This C must be in the same G. Same group. For this kind of thinking, for this Z5 under multiplication, Z5 star under multiplication. Okay. You nak tunjuk satu-satu sangat makan masa. Okay, for example, 1 binary operation with 4 will produce 4. 4 is element of Z5 star. Ni. You have many combinations of AB. You don't need to show 16 of these elements, new elements to be in the side of the same G. That's why I say it's sufficient for you guys. Suppose that your Cayley table is correct. It's sufficient if you say that based on Cayley table, your Cayley table must be right first. Kalau salah, salah lah. Based on Cayley table, all elements in tak payah complicated, tak payah formula untuk you kan. Based on Cayley table, all elements is in Z5 star. Mana saya tunjuk refer? Inilah. All elements here 1 2 3 4 2 4 1 3 3 1 4 2 4 3 1, all of them are element of Z5 star. I just need this statement with the assumption that your Cayley table is right.
Sir. What if A tu saya letak 3, B tu saya letak 4. Dan C tu saya tak dapat dekat dalam elemen tu.
Ulang balik, kalau A tu dapat 3.
Kalau macam A tu saya letak 3, B tu saya letak 4 kan. C
okay,
tu
okay.
Saya dapat.
Okay, 3, 4.
12 kan.
3, 4 bukan 12 kalau Z5 star awak. 3 kali 4.
Pahala.
Yes.
Okay.
3 kali 4 betul, saya setuju memang 12. Tapi because dia adalah Z5. Ya, 12 mod 5.
Okay.
Baki dia 2. Yes, thank you. Betul. Saya rasa ada ramai juga student section 1 saya tak tahulah. I don't know how the answer from student section 1.
So when based on the definition Z lah.
Yeah, kalau Z. Kalau ZN lain. ZN star lain. Dia kena yang tu. Beza. Okay, next question. Ada lagi? Bagus dia tanya. It's a good thing that your friend asked this. There is a common mistake. Dia juga menunjukkan, it give me some impression, ada yang tak tengok video saya. Saya tahu video saya, my video is not that good, I know, but please watch it. Mungkin I understand that some of you guys ada masalah internet. I cannot really help you on that. But during the COVID time, I really experienced what you guys experienced. I'm not in Kuantan at the time. I at somewhere else. My somewhere else don't really have a good connection of internet. When I need to do the meeting, when I need to attend a meeting, I need to drive at least 1 kilometer away. Drive lah, saya tak jalan kaki. So you guys, kalau duduk kawasan yang tak ada internet, kena usaha juga. Cuba, kalau tak boleh nak buat macam mana kan. You guys boleh tanya kawan, saya tak kisah. Video saya bukannya satu-satunya sumber belajar. Okay, continue with that. We go to the next one. The next one is associative. The definition of associative is that AB kurungan C is equal to A, B, C for every element of A, B, C in the G. This is the definition of associative. Again, you have multiple combination here, and instead of you do like this, you kena mention semua. Contoh dia, 1, 2, 3. Berapa? So I need to do 1 and 2 first. According to the KD table, it becomes 2, 3, 2, 3 berapa? 1. And do the right hand. If I do the right bracket first, it becomes 1, 1 becomes 1. So as a conclusion, you say that 1, 2, 3 equals to 1, 2, 3. You are right. I don't say you are wrong. But the problem is right now, you need to show for every. And I say in my videos as well, you don't need to show every combination inside here. The most common popular term that I say to my student is enough to say like this. As integer multiplication, in this case it's integer multiplication, right? This is Zn. Zn pun dia integer. So reasoning as integer multiplication is associative, you know that this is a fact. So Z5 star under multiplication also associative. Jawapan ni saya dengan Dr. Syam dah lama kata terima jawapan ni. You can also have a alternative answer like this. Based on properties of integer. Z5 star under multiplication is associative. Pun kami terima lah. But I really like the first one. The first one. It's so obvious. Integer multiplication associative. Maka Z5 star pun associative. You answer any of these sentences, then you will get your mark. If you answer only this blue color, you will lose the mark. Because in my bonus video, Logic and Proving, I said there is a huge amount of difference between existential quantifier and universal quantifier. Kalau for all, you kena cakap for all in the general term. Okay? Ada soalan setakat ni? Baru property kedua. Sebab tu dia 12 markah. Alright. We go to the third one. The third one is about identity. And the definition of identity is that A binary E equals to E binary A equals to A. There is some element of E in the same G such that this happen for every A in G. Alright, this one involves existential quantifier. There exists some identity such that A binary operation with E, you dapat balik A. For example, which is not the answer, not necessarily the answer. You take element A equals to 4. Is there exists 4E equals to E times 4? You dapat balik 4. You tengok dalam carry table ni. Alamak, alamak.
Satu lah.
Satu lah, betul lah. 4 betul. 4, 1 equals to 4. 1, 4 equals to 4. Yes, you are correct. Siapa yang jawab, saya tak tengok nama. Ya, itu satu lah. Tapi jangan lupa, dia cakap there exists E for every A. Itu beza sikit lah. I tak kata you salah. Yes, E is 1. Cuma just nak justify, is this only applicable to 4? Tak kan? This one also applicable to element 1 itself, 2 itself, 3 itself. Because 3 times 1 equals to 1 times 3 equals to 3, right? So what the answer that I really seek for is I need the student to say this. Yang lain tu doesn't matter anymore. Existential quantifier cukup you nyatakan satu. It's enough, sufficient for you to just mention to me what is the identity. Identity tu satu lah. Betul. And this identity is applicable for 1, 2, 3, 4 in this Z5 star. You tak jawab kanan tak apa, saya bagi dah markah. Identity exists. The student who answer E equals to 1, saya bagi markah. Yang saya tak bagi markah, if I don't give you the marks because you don't mention this E equals to 1, you just say identity exists. Cakap ni saja. If you only say identity exists, but you don't say identity is 1, salah lah, kuranglah markah. Dia jadi persoalan kepada saya. It comes a question to me. Oh, you cakap identity exists. Siapa dia? Siapa dia pula? Apakah ia? What is that?
So dekat identity tu,
Yes.
saya jalan kira E equal to 1 je lah. Tak payah nak buktikan macam panjang-panjang A times E.
Tak perlu.
Tak perlu.
In proving, I really seek the what important, what really matters. You tulis yang kanan-kanan tak payahlah. E equals to 1 cukup lah. Student seldomly mistake here for identity. Tapi kena bagi tahu nilai yang tepat. Kalau dia jawab nilai lain, salah lah. Nilai E equals to 1 cukup. Okay, yang tak cukup selalunya, okay, I speak English kan. The one that is really that student, most of them do it wrongly is at the inverse. They take very simple. They think that, okay, E equals to 1. So inverse. Inverse, the definition is given like this. A binary operation with the inverse is equal to commutatively like this. You dapat balik E. For this kind, ramai yang tulis macam ni. 1 binary operation 1 inverse equals to 1 inverse binary operation 1, you dapat balik 1. Okay, the question is, what is 1 inverse? Ada setengah student dia jawab ni je. They only answer this part. No marks here because you don't mention to me what is 1 inverse. And also, you must also mention to me what is 2 inverse. Inverse of 2, bukan English saja. What is the inverse of 3? What is the inverse of 4? Because the inverse for every element here is different. So you tengok balik Carey table. What is 1 binary operation with its inverse? You get back the identity, in this case 1. Tengoklah balik. So the trick here, not trick lah, nampak lah kat situ. Okay. 1 binary operation dengan inverse, you get identity. Identity. So the inverse of 1 is 1 itself. 1. The inverse of 2 is 3. The inverse of 3 is 2 and the inverse of 4 is itself. As my conclusion, I just say like this. Inverse exists for all elements in Z5 star. But really the answer that I seek for is this. The last sentence, if you don't write it, that's fine. But student only, this one they are wrong sometimes. They only answer for this one. For 2 inverse, they don't answer. 3 inverse, they did not answer. 4 inverse, they did not answer. That's the problem. Because the inverse must exist for every element inside. And the worst yet, they do like this.
So tak faham.
Yang mana, yang mana?
Yang start pada 2, 3, 4 lah.
Okay. If you look at the definition of inverse, inverse must exist. Tengok balik definisi ni. A binary operation inverse equals to A binary, terbalik. A, you get back E for every element in the same G. It means that I need to know the inverse for every element in Z5 star. I want to know what is the inverse of 1, which is 1. What is the inverse of 2, which is 3? What is the inverse of 3, which is 2, and 4? The inverse is 4. The students, like I said, the mistakes, they only write this one. They don't write 2, 3, and 4. And the worst yet, they just write like this red color part. Okay, 3 binary operation with inverse equals to inverse of 3 binary operation with 3, you get back 1. Dia tidak menjawab soalan. Dia hanya tulis balik definition. They just write back the definition without stating what is the inverse of 1, 2, 3, 4. Yang penting, ini yang saya cari. Ni, saya bulat lagi. Bulat lagi. Yang ni. Itu jawapan yang sebenar-benarnya. Sini saja, okay. In the yellow color here, 4 marks exist there. Imagine for the Z11. There are a huge chunk of marks given. For Z11 star, I want to know what is the inverse of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Student hanya tulis satu je. Dia kena tulis semua. It must be for all inverse. Okay, any question?
Oh, so the inverse when we multiply, we will get 1 lah, the result.
Yes, for
According
multiplication.
According to our identity, our identity E kan, E equal to A.
Yeah, betul. It must be depend on the identity, correct?
Okay, I see.
For multiplication, it's always 1. For addition, it is always 0. Okay? Commutative. Commutative lagi senang Commutative is easier. For commutative, right now I don't prove it's an abelian group yet. I just prove that it is a group. Group, you must satisfy 4 properties: close, associative, identity, are the inverse. If it's an abelian group, then it must be commutative. And commutative A, B equals to B, A. That's all. For every element in the same G. Okay. For this kind of Cayley table kind of question, again, you have multiple combination. So you don't necessarily need to write like this. 1, 2 equals to 2. 2, 1 equals to 2. Maka you conclude 1, 2 equals to 2, 1. You don't really need to do that, because if you want to do that, you have many combinations inside. So that's why we agree at this point, you can say only like this. As integer multiplication is commutative, therefore Z5 star under multiplication also commutative. Enough. Tak perlu mention satu-satu. Ada student jawab based on properties of integer. Z5 star is commutative? That is the proof for the commutative part. Number 1, number 2, number 3, number 4, number 5. 5 properties. You tengok panjang mana? Tada? Then you can conclude that Z5 star under multiplication is abelian group. 12 pakar atau 10.
Tapi kalau macam dalam assignment question ni Z11 ni kan star kan. So kena buat semua lah.
Ya. Ya betul, kena buat semua.
Okay, yes.
Beza hanya dekat Cayley table dia besar, banyak elemen je.
See?
During final, I don't think I ever put until Z11. It will be smaller than that. But not really small lah. Agak-agak dengan masa lah juga. Tapi markah for this kind of question around 10, maximum 12. Imagine siapa yang tak nak jawab soalan 5 tadi? Saya tak ingat nama. Some of you guys just now. Can I concentrate on chapter 1 until chapter 3 saja? If you master this chapter, you tengok balik, you study balik, tak susah mana. You just need to mention some of the properties. You need to do the Cayley table. Okay, if you manage to do that, you can secure 10 over 100 easily. If you study the videos, the slide, and also you understand the know-how. Okay, so that's why jangan skip. Okay, take a break for 5 minutes please before I continue back with a little bit of these questions. Sekejap saya tunjuk soalan apa. Soalan macam mana nak bagi terbalik soalan ni lah nanti saya bincang ini. Z5 elemen. Oh, Robin, saya tak baca lah. That's why saya kata kalau boleh cakap, sebab bila saya buka dua tu saya tak nampak. Okay, tak apa, saya jawab. Robin, Z5 elemen dia bukan 1/5 ke? Itu Z5 0 ke 4. Z5 star. Oh, ni Robin ke yang cakap dengan saya tadi?
Ya saya.
Okay. Sir, if the question is plus, the close is A plus B. Plus lah. It must be according to the binary operation. When we talk about binary operation, there are multiple operations. Okay? Plus, multiply, minus, divide, union, intersection, macam-macam binary operation. It must be according to the question. Alright, take 5. Then we will continue back. I will not close the recording sebab dia bersambung. Take 5 2:40 we start back. Jap, iklan jap. Siapa pernah tengok buku ni? Macam mana nak tengok Tak boleh lah, dia tak ada cermin. COVID Ball Z. So it is a combination between COVID and Dragon Ball Z, written by Ernest Ng. Korang kenal tak ni siapa?
Takkan tak kenal.
No, sometimes when they draw dia siapa? Muhyiddin. Ni? This is a very funny comic. Tun M. Okay, you can write. You can buy this, or you can read online. It's Ernest Ng. COVID Ball Z. I think you guys ada baca lah, cuma korang malu nak cakap. Take 5, saya baca komik je. Gitu kan? Okay. Okay, I'm back. All right. I experienced that some of you guys have some problems with the elements of matrix. So I will mention a little bit on matrix first, then I concentrate on the question that your friend asked me. Okay, the assignment is finished, okay. Okay. I know for this question, you nampak kat sini. Apa? Okay. There are many kinds of G, of course, and there are many kinds of binary operation. But you make only concentrate the one that I focused on in my video lecture. You not necessarily need to understand the Q here, the multiple of 6Z, ini multiple of 6. Ini 6 to the power of n. Ini adalah bentuk A plus B squared. Saya tak ingat nama. Because this question is from Dr. Muhammad Sham. So I think that it is too much kind of G that my students need to learn. That's why I focus on Z, Zn, Zn star, Un, and also matrix. What I really want to focus on is the element which involve integers. Q including rational number, it includes fraction. So I do focus on the fraction. Ini lagi lah A plus B cert tu. This is lagi lah irrational, not integer. That's why I don't teach the things which is not integer, because integer is discrete. The others is not. Rational number is not discrete. The cert is not discrete. So don't worry. All right, but this one you need to worry lah, matrix, especially when it involves integer as the input. Okay. All right. Mana pen? All right. 2 by 2 matrix. Matrix, if you see this M2 Z, regardless of the binary operation, it means 2 by 2 matrix. A, B, C, D. This A, B, C, D is an integer. That is the meaning of that. M2 means 2 times 2 matrix with the input integer as the input. Now let's change a little bit to this form. M2Z plus. If you get this M2Z plus, it means the binary operation with plus. So how do you add two matrix? How do you add two matrix? This thing you already learned during your previous level of education. It will become A1 plus A2 as the first element, B1 plus B2 as the first element, C1 plus C2, and D1 plus D2. Okay? It becomes another thing, right? A1 is an integer, A2 must be integer, becomes another integer. All of these are integer. So at this point, you may already see the elements of matrix addition is closed. Okay, now comes to the different kind of question like this. Given a matrix, 2 by 2 matrix, but the element might be like this, A, 0, 0, B, right? How come there is no B and C or D? Okay, this still is a subset of M2Z. 0 is an integer, so no problem if you get this kind of representation. However, how do you want to edit two matrix? A1, 0, 0, B1. Suppose you get this kind of special matrix, A, 0, 0, B. How do you add this one? It becomes like this. A1 plus A3. This one still 0, 0, B1 plus B2. Right? Kejap, saya on mic ke tak? On, okay. Nota. Sorry. It still becomes something else like this. A3, 0, 0, B3. This A3, B3 is an integer as well. You see, 2 by 2 matrix, I repeat back, be it any operation. For this example, I put plus, and this is how you add up matrix. And if I change a little bit into A00, B, you still can add the matrix. And comes the question from your friend. Okay. Your friend's question is in the previous final exam, I suppose. You get this kind of A plus B, 0, 0, A minus B. And of course, this AB is an integer. The operation involved is plus. Soalan dia under addition. How do you add the matrix? You take the first matrix, M1 becomes A1 plus B1, 0, 0, A1 minus B1. Apa ni? Sorry Okay. The second matrix becomes A2 plus B2, 0, 0, A2 minus B2. And how you add up M1 plus M2? It's the same. The difference
A1
just
plus A2 plus
betul,
plus
betul.
A2 B2.
A1 plus B1 plus A2 plus B2, 0
Kosong,
plus 0,
kosong.
kosong, kosong. Ni A1 minus
Minus
B1.
B1 plus A2 minus B2.
Senang je. There's no complicated about the matrix. Just we change the elements to be a slightly bigger element. Okay? Betul. Thank you for the cooperation. This one becomes another element, this one becomes another element. No difference. Not so much difference. This one maybe I can categorize like this. A1 plus A2. Saya sajalah kumpul A dengan A. Plus B1, B2. 0, 0. This one A1 plus A2 minus B1 plus B2. Settle. You must master how to do the binary operation first. For the plus, macam ni kita tambah matrix. For multiplication, how do you multiply the matrix? I think I also mentioned already in my video lecture. Pun korang dah tahu. Beza dia apply dekat abstract algebra sahaja. Now, we try to answer this question. This one, the last one. A plus B, 0, 0, A minus B. Right now, I already show you how to add up the matrix like this. And of course, this thing becomes another integer. This one is also an integer. Saya tak ada space. Ada space lagi. Okay. Is it closed? The question. If I want to answer close, I must show the first plus first. I already plus this one, and it becomes this final matrix like this. To understand closure, closure cakap, the definition of closure for this question, sorry, terlepas. The general form is A plus B, 0, 0, A minus B. This A, B must be integer. So the thing inside here must also be an integer. But this is only the one matrix. However, M1, the first element, M2, the second element, will produce the third element, which is M3. Thus, this M3 is an integer. To answer closure for this one, it's very simple actually. If A1, A2, B1, B2 is an integer,
mesti dapat integer.
Mesti dapat integer, betul. Tapi, okay, but because this is a true for every integer out there, A1 tu apa-apa integer, A2 is every integer, B1 apa-apa integer, B2 sama. Dalam ni integer lah. So, I need to have this statement. A1 plus A2 plus B1 plus B2. Okay, I can accept if the student answer only like this. This one that I sought for, that I seek for. Ini, this one is an element of integer. 0 of course integer, that's why I don't want to mention it. This one, A1 plus A2 minus B1 plus B2, also integer. So for every A1, A2, B1, B2 is integer, the binary operation A1 plus A2 plus B1 plus B2 is also an integer. A1 plus A2 minus B1 plus B2 also an integer. Therefore, this matrix ni bukannya M2 technically, I can say that bolehlah M3 is closed. You get 1 mark based on this point. Close A, B, produce new element, the new element in the same G. In this case, this G is the matrix in the form of, alamak, in the form of this. Okay? As you realize, I try to put in this form back. A plus B, this is A minus B. The same structure. Okay? I need to have some space. Ada space lagi? Ada. Alright. For the case of associative, okay, it will be slightly longer, but it's sufficient for me to just show associative. It involves 3 elements. So I need to show like this. A1 plus B1, 0, 0, A1 minus B1 plus A2 plus B2, 0, 0, A2 minus B2. Plus, ada 3 matrix. Kalau associative, it must ABC kan? So ada 3. Okay, I need this statement. This can be your final answer already. Like this. The first bracket, this is M1, M2, M3, is equal of this. Alamak, tak ada space. It's equal with this. Alamak. Yeah. For every A1, A2, A3, B1, B2, B3 is in this M2. For every which is an integer. Therefore, I can say that this M2 is associative. Okay, at this point, some of you might question me, why this question becomes only like this? Because this is universal statement, universal quantifier for all. And because this is true for every integer, you must put in the general variable. You cannot put 1, 2, 3, tak boleh. You cannot do that. For all, let's like this. If it is true. Existential, then you need to put the value. Okay? So, I already covered closed and I already covered associative. Alright, how about identity? Okay, again, the general form of matrix is this A plus B, 0, 0, A minus B. You try to think for a little while. What is E1, E2, E3, E4? This is represented as the identity E, matrix identity. Such that it will produce commutatively, saya tak tulis, it will produce back A plus B, 0, 0, A minus B back. My question, what is the element of E1, E2, E3, E4? Apa dia? Existential you cannot put in the general variable. It must be a value. Apa dia?
Kosong.
Adakah kosong? Tak habis lagi?
Kosong.
Kosong, habiskan Barulah, this is the identity matrix for this matrix addition. Betul. Tapi jawab habis lah. Saya tak tahu siapa cakap tu. Tapi kosong. If the student answer only kosong, salah lah. It must be in the form of this matrix. So identity exists, and the matrix that I search for that produce mark is this. Because this is very true. If A plus B plus 0 dapat balik A plus B. 0 plus 0 dapat balik 0. 0 plus 0 dapat balik 0. A minus B plus 0 E4 becomes A minus B. And the blue color here is the answer that I seek for. We continue with the inverse after we know that the identity exists. Huh? Given that the matrix is this form, A plus B, 0, 0, A minus B. And you know that the identity matrix E is 0, 0, 0, 0. What is M1 plus M1 inverse becomes E? Commutatively also is true. So it means I need to know what is A plus B 0, 0, A minus B, plus the element inside here, you get 0, 0, 0, 0. You do some linear equation, solving some linear equation, it will be quite easy to see that the inverse matrix is negative A,
Negatif B.
betul, thank you,
Kosong.
0, kosong, dia apa?
Negatif A, positif B.
Betul. Inilah jawapan dia. This is the answer that I need to see. For the existential quantifier, there exists inverse. What is the inverse? This inverse.
Yes, the inverse.
Siapa kata susah tak susah? Kalau you faham the definition. So the the inverse exists. So as I already showed that it is closed, and this is associative. It says identity 0, 0, 0, and this is the inverse. Therefore, from 1 until 4, this A plus B 0, 0, A minus B, under addition, is a group. Okay, I know some of the question from your friend, it asks for the subgroup. Subgroup, what is the properties that you need to prove? In the subgroup, you have two kinds of tests, 1 step and 2 step. And in my video as well, and in my face-to-face lecture, I always advise you to do 2 step because it is much clearer, it's much more precise, is that you must show that as this closure, that it is closed, and the second one, it must have inverse. So for this question of a subgroup, if I show the first one, the closed, closed under binary operation of G. The difference between subgroup and group, subgroup, there exists 2 sets, H and G. H must be a subset of G, and this H must answerable to the binary operation of G. Itu je beza dia. Tetapi if I want to answer subgroup, I need to show it is closed under binary operation of G. Associative tak payah, identity tak payah, and directly to inverse. But bear in mind please, to answer inverse, you must know the identity. Although I really do not want to see this is not included in the marks for the subgroup kind of question, but in order for you to produce this inverse, you must know the identity first. The marks is at the inverse, not at the identity. So I hope that answered the question from siapa ni? Siapa tanya saya semalam? Kejap. Saya cari nama dia jap. Soalan daripada Fatin. Oh, dari DMA section 1. Ada ke Fatin dalam ni? Fatin? Lah, saya silap baca. Dia section 1. So, sekejap. Fatin, saya jawab mesej dia jap semalam. Fatin, saya akan bagi link video. untuk jawab soalan awak. Kepada Madam Anis. Okay. Alright. That is the properties for this kind of question. Okay, commutative. Saya habiskan for commutative. Oh, ada yang dah keluar, tak apalah. Saya tak ada masalah. Okay, for commutative, for this kind of group, I take the first matrix, M1. It is A1 plus B1, 0, 0, A1 minus B1. And I have a second matrix, A2 plus B2, 0, 0, A2 minus B2. Okay, I just need to show this statement. A1 plus B1, 0, 0, A1 minus B1 plus A2 plus B2, 0, 0, A2, B2 is equal when I interchange the position to left to right. And this thing is true for every A1, A2, B1, B2. Commutative. It's like the answer like the associative just now. But I cannot put the value because this is true for every possible A1, A2, B1, B2, which is an integer. That's all. So when I already proved this fifth characteristics, the fifth properties, now I'm sure that this matrix addition for this kind of form, A1 plus B1, 0, 0, A1 minus B1, is a abelian group as well. Okay? Ada soalan setakat ini? You have question for the time? Okay, if not, I will finish with their actual question. No, ada satu lagi soalan kat situ. About cyclic subgroup. Okay, saya buka nota cyclic kejap. Okay, cyclic subgroup. Okay, I think I don't want to show this. I think you can look at my video lecture on how to produce the elements for the case of cyclic subgroup. I will definitely only focus for this question. All right. For this kind of matrix, okay, it's because in the slide there is no matrix addition, tak ada for the cyclic groups. So I happen to show you the solution. Okay. Cyclic subgroup means there exists a generator. Generator in the form of A binary of A to the power of n. Okay, ini maksud dia. Right now I have A plus B, 0, 0, A minus B. And this AB is an integer under addition. Okay, please open your perspective of thinking. This A and B is not A and B only, it's every integer. Okay, so every integer plus every integer, 0, 0, every integer minus any integer. Does exist the generator? Generator means that A plus B 0, 0, A minus B, you add up with some generator here, G1, G2, G3, G4, it will produce a new element A2, B2. And then after that, using the second matrix A2 plus B2, 0, 0, A2 minus B2, you add up with the same generator, it will produce another element. This is the first cycle. I generate one more, I add up with some generator, the same generator again, it will produce another element A4 plus B4. 0, A4 minus B4. So imagine an infinite sequence here. What is the G1, G2, G3, and G4 that will always produce another element every time? Okay, this is in the abstract manner. Number abstract algebra, maka ini abstract. I tunjuk contoh yang tidak abstract. It means I put the value this time. Let's say this A1 equals to 1 atau 2 lah, saya letak 2. A2 is 1. Okay, pay attention please. Okay, what will be my matrix? It becomes 2 plus 1, 0, 0, 2 minus 1. What is the generator such that it will produce new element here? Okay, my hint is like this. It becomes
Sir, A2 to B1 kan A2 equal 1. B1
oh,
equal
B1
equal 1.
Okay, thank you. It's B1, thank you. Okay, apakah G1, G2, G3, G4 that it will produce new element? Right now, this element is this, right? Sekejap saya padam. Takut tak nampak. Okay, right now it becomes like this. Saya tambah I actually will add up this one. It becomes 3, 0, 0, 1. Tambah apa? Dia jadi elemen baru kat sini. Sini mesti 0. To maintain, to preserve the structure of 0, 0. What will be this 4? And maybe perhaps this is 0. Contoh. This question is a little bit hard. I agree. But the idea right now is just to know what is G1, G2, G3, and G4. Perhaps you can know that this 0 never changed, right? Daripada iteration, the previous iteration here, you can see this 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I happen to have to hypothesize is that this is 0, G3 is 0, and this is G4. At least you have that idea. Okay. Right now, I back to this part. Assume 2 plus 1, 0, 0, 2 minus 1. I plus 1, 0, 0, 1. I assume that this is a generator. How will my answer be? Tengok. It becomes 2 plus 1 plus 1, 0, 0, 2 minus 1 plus 1. At the end, we become 4, 0, 0. Ini jadi apa? 2 tolak 1, 2. Okay, the question is that kalau the previous one is 3, 0, 0, 1, this one becomes 4, 0, 0, 2. It becomes a new element, right? Okay, saya ulang balik. You tengok balik yang step asas ni. Okay, this part. Every new iteration, every addition, it will produce another value. And this is not only for 3 iteration. Assuming infinite times of iteration, it will produce all integers out there. So what will be G1, G2, G3, G4? If my previous A1 is 2, my B1 is 1, it will produce 3001 here. It will produce 4002. Kalau I proceed 4002. If I transfer into form of A2 plus B2, this A2 and B2 is still an integer. Kalau saya cuba pecahkan, dia boleh jadi integer juga. It can be 2 plus 2, 0, 0, 2.
2 minus 2, 0.
Tak apa. Oh, 2 minus 2 is 0. So dia tak boleh 2 minus 2. Dia boleh jadi 4 minus 2. My point right now is still inside here, this A2 and B2 must be still an integer. Itu maksud saya nak cakap kat sini.
Okay.
Bukannya it cannot be it must be 2. No, it does not say that. The elements inside right now, this is A3, B3. When you try to pecahkan, separate it, this must be still an integer because this is an integer. There still exists an integer A2, B2. A2 and B2 can also be an integer. Right now, 4002, you plus 10, 01 is still will produce another 5003, and this 5 can also consist of summation between two integers. This 3 also will be we consist of a summation of two integers. So as it point out, for this question of cyclic subgroup, you must tell me what is the generator of G1, G2, G3, G4, and the generator is 1, 0, 0, 1. As there exists the generator which can produce every integer inside A1, A plus B, 0, 0, A minus B. Therefore, A plus B, 0, 0, A minus B, such that this A and B is a integer under addition is cyclic. This is one of the hardest question that we ever did, to be honest with you guys. And the sad thing about this, when I teach this, saya time tu, this is 2 years ago. Dan ketika soalan ini ditanya, yang buat saya teringat perkara ni because keesokan harinya, the next day, I found about these tips saya bagi kat student dalam toilet DBP. Sehari selepas tu BPA jumpa jawapan ni dalam toilet. It means that there exists some students who cheat this subject 2 years ago. Specifically this question. Saya ingat sebab dia tulis 1001. That is one of the occasion that I will never forget. Memang soalan ni susah, sebab tu saya cuba tolong time tu kan. Kita bagi sedikit hint lah. Actually the metric addition, the cyclic subgroup, the generator selalunya 1001. Dia boleh 100 negatif 1, boleh juga. Kalau ada setengah-setengah case. So that's why I just happen to tell you the story lah. There will be a easy question, there will be a hard question, of course. Kalau tak, dia bukannya final exam, I cannot distinguish your performance. Ada budak A, ada budak B, C, D, ada juga budak E dengan F. Most of my students will fall between C to B+. Okay. However, for this semester, I think the percentage of A will be quite higher. Alright. Itu je yang saya boleh beritahu you all. Alright.
Itu berita buruk ke berita baik tu rasa? Quite higher tu mark percentage tinggi ke ramai dapat A?
When I try to do a forecast, markah tinggi banyak dekat test. Okay. I don't want to accuse my students of anything, but logically speaking, mestilah ada kan. But I'm fine with that. Saya dah termasak dah dengan benda tu. Kejadian yang saya cerita tadi tu antara yang paling saya sedih sejak saya kerja di UMP. Lepas tu saya dah kira I already try to teach a good value. From the first day I work here, I teach my students try to be honest. It means if you study sincerely, you study focus apa semua, you do honestly, you macam mana pun you susah you mesti boleh jawab. Dan kalau you tak dapat jawab pun, I pasti you boleh pass. That is my doa bahasa Inggeris apa? Doa lah. My doa to you guys, to those of you who study this sincerely, however hard that they will get, they encounter, they will pass. Itu bukan jaminan saya, itu doa saya. To those of you who studied insincerely, however good their mark is, I still wish them the best. Sama juga. But please do not do that. I can teach you this same question multiple times, but I cannot accept the student who did that. Itu je lah. Kita biar bodoh tapi baik. Saya ada student, saya tak mau cakap dia bodoh, tapi kasar dia bodoh. Dia sendiri cakap dia bodoh kat saya. Tapi lah sekali sekarang dia dah kerja. Alhamdulillah. Dah kahwin dah pun. Sebab doa dia saya kepada dia, walaupun dia belajar tak pandai, tapi dia akan berjaya dalam hidup. Sekarang ni dia dah berjaya lah. Dah ada kerja dah.
Betul.
Itu yang penting. Belajar ni hanya belajar. Tapi kalau you menipu dalam belajar, nanti you buat apa pun tak akan berjaya di akhirnya. Okay. Ini bukan tazkirah lah. Ini penutup lah kot. Sebab dah lama lah ni, 3.24. Okay, now my question to you guys. Ada tak soalan lain untuk ditanya pada session ni? Is there a question for you guys to ask me for this presumed first session? I cannot guarantee there will be a second session, of course. Sebab you guys ada exam dah lepas ni. Saya pun kena jaga exam 5 hari bulan ni. Saya cuba buat. Dan I think if I want to do it, it will be tomorrow. Tapi sebab tomorrow pagi saya ada meeting sampai tengah hari. The best time that I will give to you is after Jumaat 2:30 sampai 3:30. Boleh? Okay? Maybe 1 hour until 4 lah. 2:30 until 4. I will do another announcement. I will do a second session tomorrow. To those of you who can attend, please attend with mana muka saya. Okay, you can attend tomorrow with a question lah. Datang dengan soalan. Soalan mana yang susah? Macam tadi tu saya dah jawab soalan yang kawan kamu tanya dalam WhatsApp. So tomorrow soalan lain pula. Boleh? Kalau yang hari ni nak attend lagi lah. Kalau tak nak, tak apa. I understand. Dalam belajar kita tak boleh paksa. Ada soalan lagi tak setakat ini? Ini ke Fatin yang tanya saya soalan tu? Nur Fatin Syahidah. Assalamualaikum doktor, saya Fatin dari DMA. Saya nak tanya soalan ni. Kamu ke yang tanya? Oi Fatin! Okay, dia tak mau jawab, tak apalah. Saya rasa dia tidur. Okay, mungkin dia tidur atau dia pergi masak. Oh, dia jawab dah.
Jawab.
Oh boy. Alright, dia malu Okay, it's okay. Again, the same. Next question tomorrow. If you don't have question right now. Okay. It's been a good. Sir, we'll provide. No. Okay. This is a mathematical formula book. Why I said that it will not be provided to you guys? Because the formula inside here does not include the one that is for DMA. But if you worried about the set identities, ada kan slide set identities tu, saya cakap je, saya tak tanya. Kalau kalau saya tanya pun dia mudah. Dia boleh dibuktikan, it can be proved by a simple logic. A intersect empty set. Dia sama dengan apa? Tak perlu formula pun. Saya ulang set A. Suppose it's non-empty, you intersect with an empty set. You dapat apa? What you will get?
Kosong.
I know. Ni seorang lagi pula. Jap. Kejap. I tak nak tutup lagi. Berani jawab macam tu. Okay. Imagine A non-empty set. This is a set. Intersect dengan empty set. Bukan dapat kosong. Kalau budak tak nampak, A katakan 1, 2. Okay. 1, 2. Intersect dengan empty set. Dapat benda. Oh, kosong Dia tak ada intersect. Betul lah awak. Sorry.
Kosong
Kosong. Bukan kosong technically.
I mean, set tu kosong, tak ada apa.
Yes. Set tu kosong. Bukannya kosong. Kalau kamu jawab kosong, dia tak betul. Tanya. Kalau A union empty set,
dapat 1, 2 lah.
Dapat 1, 2. Betul. Terbaik. Senang je. Tak payah hafal. Memang tak payah hafal. Soalan saya tak banyak. We just need to show the generator is 1001. Yes, you need to tell what is the generator and then your conclusion. Jangan tunjuk generator saja. You must, okay, the generator is this. Therefore, it's a cyclic subgroup. Because the question asks about whether it's a cyclic subgroup or not, right? Determine whether it is a cyclic subgroup. In order to have a cyclic subgroup, you must have a generator. As there is this generator, therefore it's a cyclic subgroup. If the problem if it is not a cyclic subgroup, you must say with some proving is that there will never be a generator. Itu susah sikit. Tapi kena ada soalan. Thank you. Oh, C okay. Okay, next question. Right now you have the momentum, right? After you listen to the lecture today, I hope you have the drive. The drive is, banyak benda aku tak study lagi. Macam tu lah kan. That's fine. So tomorrow, malam ni boleh study sikit. Settle your hostel. Settle your everything. Get ready for your assessment next week. Bila kita punya DMA? Bila? Pagi ke petang? 6 pagi. Pagi ke?
2:30 PM petang.
Aduh. Saya pun tak faham. Asyik-asyik DMA. Tika kata pagi. Cek ya.
Tak ada. Saya tengok sleep ni. 2.30 sampai 5.30.
Okay.
6 hari bulan 10.
Okay, tak apa. Atika tersilap. Yang saya tak puas hati, DMA selalu buat petang. Matematik dia kena pagi.
Betul.
So tak boleh buat apalah, benda tu bukan yang kita kontrol. Okay, so see you guys and the non-attendees tomorrow at 2:30 until 4. Okay, thank you so much for a very good session today. See you guys tomorrow. Okay, bye-bye.
Thank you, sir.
You're welcome.